Section 1.5, solving inequalities. So here we're looking at solving inequalities, and then we're going to have to graph their solutions on a number line. So concept refresher. So here we're looking at various inequalities and then how they are worded and then how they would be graphed accordingly. So for the first one here, this is x is greater than 4. So we're looking at x all right, and so that is the greater than symbol, in case you're curious. And so to graph this, at 4, we're going to have an open circle because in this case, the greater than symbol as well as the less than symbol without the bar underneath it have open circles, meaning that they don't actually touch that value there. So we've got an open circle, and in this case, we're greater than, so we're moving towards the right because that's where 5 would be, as 3 would be on the other side. All right, x is greater than or equal to 4. Very similar. Except in this case, with the greater than or equal to symbols, we're going to have closed circles because they actually touch those values. So in this case, we go to 4. We know 5 is to the right, 3 is to the left. This time we're going to color in that circle, and then we're going to have our arrow going to the right. So very similar down here. These are both our less than. So we'll just go ahead and write the words less than, and then less than, or equal to. And so same idea. We're going from 4. We're going from 4. We've got 5. We've got 3, 3, and 5. Less than, once again without the bar, open circle. This time we're going left. Here, closed circle because it's equal to, going to the left. So here we're looking to solve and graph inequalities. So same thing as solving a equation with a few variances. So let's just kind of see what we have here. We're going to distribute the negative 3. So that's negative 6x plus 15. Plus 1 is greater than or equal to 4. In this case, like terms, negative 6x plus 16 greater than or equal to 4. We'll bring the 16 over, so we'll subtract it. I want to get our variable alone. Negative 6x is greater than or equal to, in this case, negative 12. And here's where the variance happens. Anytime you divide or multiply by a negative number when solving an inequality, you have to flip your inequality symbol. So I'm dividing by negative 6, and when I do this, it becomes x is, oops, wrong way. So we've got x is less than or equal to 2, and so our last step here would be to graph this. And in this case, we have a closed circle because of the equal to, and it's less than, so we're going to the left. Question B, same idea. We'll go ahead and distribute. We've got negative 2x minus 18 plus 5 greater than or equal to 3. We can combine like terms in the negative 18 and 5, so that's negative 13. So negative 2x minus 13 is greater than or equal to 3. We're going to go ahead and move the 13, or negative 13, by adding 13 to both sides. We've got negative 2x is greater than or equal to 16. Once again, we're going to divide by a negative, and when we divide by a negative, that's when we flip the inequality symbol. If you're dividing by a positive, it doesn't change anything. It's only when you divide by a negative. So in this case, we're going to get x is less than or equal to negative 8. So in this case, we've got negative 8, negative 7, negative 9. And because it's the less than or equal to symbol, it's going to be a closed circle, and we're going towards negative 9 or to the left. All right, so more of the same, except this time it says no solutions are all real number solutions. So we're going to go ahead and start solving these, and we're going to see something special take place. So in this case, we've got negative 2 times the quantity 3x plus 1 is less or greater than negative 6x plus 7. So we'll distribute. In this case, we've got negative 6x minus 2 greater than negative 6x plus 7. We're going to get our variables to one side, so we'll go ahead and add 6x. I've got negative 2, because these cancel, is greater than 7. And in this case, negative 2 is never greater than 7, so this is false. And so this is no solution. Question B, similar idea. Go ahead and distribute. You've got 10x minus 15 minus 7x is less than or equal to 3x plus 8. We're going to combine our like terms in 10x and 7x. So that's 3x minus 15 less than or equal to 3x plus 8. 3x on the same side, or get rid of it. So subtract 3x. Negative 15 less than or equal to 8. That's true. And since negative 15 is always less than 8, this would be all real number solutions. Now we're looking at solving what they call an AND inequality. And so the AND inequality can be written two ways, with the word AND in between the two separate inequalities, or as a compound inequality. And so we'll look at both. So here we're going to solve these two statements separately for right now, and we'll keep track of them as we go. So on the left one, we're going to subtract 1. So we've got 6 is less than 2x. We'll divide by 2. And we're going to get 3 is less than x, or in this case, x is greater than 3. On the other side, we've got 3x is less than or equal to 18. So we're just going to divide by 3. And we get x is less than or equal to 6. And so we can graph this on a number line. And we just got to make sure we have the word AND here, because these are our two solutions. And so 3, we got 6, 4, and 5. Let's say 2 is here, 7 is here. All right, so x is greater than 3, essentially, or 3 is less than x. So if x is greater than 3, we're looking at going this way. And then x is also going to be less than or equal to 6. So at 6, we're going to have a closed circle, and it's less than. And what we're looking at is we're including the area in between. And this is kind of common for AND situations where you're looking for a middle ground. Question B, same idea, except we're going to solve both ends of this inequality at the same time. We could separate it, but it's just easier to solve it at the same time, I think. So add 2 here, add 2 here, and add 2 here. So we're canceling from the middle. Now we've got 5 is less than 5x, which is less than 9. We're going to divide by 5. And so now we've got 1 is less than x, which is less than, in this case, let's just change it to 1.8. And so we've got 1 here, and then we'll say 1.8 is here. If we want to put 2 here, we can. We can put 0 here. So because of how this is written as a compound inequality, it's really easy to graph this. And ideally what we're going to do is we're going to have an open circle at 1. So an open circle at 1 and an open circle at 1.8. And we're looking at joining them in the middle. Basically, we're defined in between those two values. Now we're talking about solving an OR inequality, similar to AND, but has different properties of its own. So for the A value here, we're going to go ahead and look at solving this. So we're going to subtract 7 from both sides. We've got k greater than or equal to negative 1. Or in this case, and we'll solve this one, we'll subtract 8 from both sides. And this time we have k less than negative 5. So we've got k is greater than or equal to negative 1, or k is less than negative 5. And so as we go to graph this, we're going to see how this differs from the one we just saw. So negative 5 here. Put negative 3 here, negative 1, and 0, and let's put negative 6 here. So at negative 1, our k value is greater than or equal to that value. So to be greater than or equal to, closed circle, going to the right. Or k is less than negative 5. So open circle at negative 5, going to the left. Notice how the two graphs diverge. They go in the opposite direction from one another. Let's go ahead and solve b as well. Same idea, we'll solve each of the two inequalities separately. So negative 3, so subtract 3, 7w, greater than, in this case, 8, divide by, not w, divide by 7, there we go. And so w is greater than 8/7. That's not good writing, there we go. Or, and then we go to the other side, we're going to go plus 1, plus 1. We've got 4w is less than, in this case, negative 12. Divide by 4. And w is less than negative 3. So we've got w is greater than or equal to 8/7, or w is less than negative 3. All right, so we're going to go negative 3 is here. We'll put 0 here. And then we'll go 8/7 is here. All right, so w is less than negative 3, so open circle at negative 3, going to the left. W is greater than 8/7, open circle, going to the right.